Howdy, groovy babies. It's your boy. Yesterday I skipped this one because I didn't understand it. But I'm gonna attempt it now. I'm gonna show you guys how to do it. So we're gonna start off with our. I'm gonna start off here. The z transform of h of g of s is equal to z of 1 minus e to the minus st over s, and that is hold on. That is multiplied by kp over all right. So the the first thing we're going to do is factor out this common expression here, like we did with all the examples yesterday, which is 1 to the e minus st. Then you're going to have this expression here now. Did I write that incorrectly? Okay, I see what the problem is. This isn't supposed to be here. Alright, so now all you're going to have here is kp over s tau p s plus 1. Alright, so you can go ahead and transform this. So it's going to become 1 minus z to the negative 1. That's multiplied by this kp over s tau p s plus 1. Right, then what we're going to do is factorize this kp because we don't need it. It's a constant. 1 minus z to the negative 1. Now we want the z transform of 1 minus s times tau p of s plus 1. Okay, so in order for us now to get this into something somewhat of a standard form, in order to transform it using the available transforms on the table, we're going to divide by TP. C minus 1 C. So doing that is going to change the numerator to 1 over TP over S multiplied by S plus 1 over tau P y. Now, what do we need to do in order to simplify this? We need to use partial fractions. So we're going to consider this in isolation now, and I'll run it over here. So uh, S plus 1 over tau P 1 over tau P. No, that's so bad. It's going to be equal to A over S plus B over S plus 1 over tau P. then simplify that, you'll have 1 over tau p equals to a s plus 1 over tau p plus b of s. Now, carrying on with the process of finding our constants, we're going to evaluate s being 0 and s being negative 1 over tau p. So first, for s being 0, you have 1 over tau p, which is equal to a 1 over tau p plus 0. Then to get a by itself, we just multiply both sides by tau p. Therefore, a is equal to 1. Okay? Then for b, we're going to look at s equal to negative 1 over tau p. That's going to give us 1 over tau p, which is equal to, what's this? Yeah. This is going to cancel out, so I'm just going to go ahead and write 0. B times minus 1 over tau p. Cool. Then again, do the same thing. Multiply both sides. Now by negative tau p, which means that b is equal to negative 1. Alright. So then if we take this here, we're going to have, I'll continue down here, kp 1 minus z to the negative 1 multiplied by the z transform. So a is 1, so it's 1 over s. B is negative 1, so it's minus 1 over s plus 1 over tau p. Alright, so now this is in a standard form. So if you look at your table, you've got your 1 plus 1 over s plus a, and this unit step transform. So that's equal to kp times 1 minus z to the negative 1 that's 1 over 1 minus z negative 1 minus 1 over 1 minus e to the negative t over tau p. There's not going to be minus. So we're looking at this here. A is now 1 over tau p. So we just input that there and then multiply by z to the negative 1. Cool. So let's continue. Kp away. This becomes 1 minus e to the negative t over tau p z to the negative 1 minus 1 minus z to the negative 1. Right, that's all over this product here, 1 minus z t over tau p z to the negative 1. Okay, so you can see that this is going to cancel that. Okay, p is multiplied by, so when this multiplies out, it's going to be negative 1, which will cancel with that one. Then this is going to become positive z. So what will be left is z to the negative 1 minus e to the minus t over tau p z to the negative 1, right? And that's all over 1 minus e to the minus t tau p z to the negative 1. Cool. Then all that's left to do is factorize the z out and then multiply that by kp. So it's that 1 minus e to the minus t over tau p times z to the minus 1 over 1 minus e minus t over tau p z to the negative 1. And that is what you've got here. Lacquer. Let's see this. Then here, the step response for this first order lag system, all you're doing is multiplying this transfer function now in the z plane by the z transform of the step. So that original function multiplied by this now. Then what they do here? Multiply that out. Then split it up. That looks like partial fractions again. But yeah, you get the point. Then you can take it back to the discrete time zone. Using your table.